Let's jump right into this explainer. Today, we're tearing down the hood on how a computer actually works. We use them literally every single day, but what's the actual fundamental logic powering everything from typing a simple word to running a massive video game? Well, let's demystify it.
Here is our agenda for today. First, the IPO cycle explained. Second, computers versus calculators. And third, an interactive quiz challenge. All right, Section 1, the IPO cycle explained. To kick things off, we really have to remember one fundamental truth about computers. They can't work on their own. They desperately need us, our letters, our numbers, our instructions, to even start functioning. So the crucial point here is that every single computer, no matter how ridiculously complex, operates on this core top-to-bottom flow known as the input, process, output, or IPO cycle. It's basically 3 steps. First, it takes data in. Second, it works on that data. And third, it gives you a final result.
Think about a washing machine to kind of picture this. Your dirty clothes, that's the input. It's what you feed into the system. The machine actually tumbling and cleaning, that's the processing phase. And those fresh, clean clothes you pull out at the end, that is your output.
Let's build on this with another everyday analogy, making breakfast. Dropping fresh fruit into a juicer is your input. The blade spinning around and crushing it all up is the processing. And pouring that refreshing glass of juice is the ultimate output. Input, process, output. It really is a universal rule. Now, translating this back to our digital machines, input refers to the exact data and instructions we're feeding into the computer. Obviously, we aren't using dirty clothes or fruit here. We're using numbers, letters, and clicks. And we enter this data using specific input devices, most commonly, a keyboard or a mouse.
Once that data is actually inside, the processing begins. This means the computer is crunching the data, performing calculations, and following your instructions to the letter. And this heavy lifting, it's handled entirely by the CPU, the central processing unit. It's basically the brain of the whole operation, doing the critical work behind the scenes.
Finally, we hit output. This is the result of all that hard work the CPU just did. When it finishes processing, it has to give the result back to you. Usually, you're going to see this pop up right on your monitor, maybe printed out on physical paper by a printer, or even hear it as sound coming through a speaker. Moving on to Section 2, computers versus calculators. What's super interesting here is how this comparison perfectly highlights why a computer is just so much more powerful than a standard calculator. I mean, they both do calculations, but they are playing in entirely different leagues.
Think about it. A standard calculator is strictly limited to crunching numbers and showing you one single result at a time. A computer, though, it effortlessly juggles numbers and alphabets, displaying multiple complex results, windows, and graphics all at the exact same time. And the feature gap is just massive. Computers are fully programmable to do pretty much anything. They have enormous memory banks to store years of data, they process at lightning speed, and you can even access them remotely from across the globe. A calculator is non-programmable, has very little memory, is pretty slow by comparison, and completely lacks any remote access.
All right, Section 3. Interactive Quiz Challenge. Time for the Play Along segment. We've covered the core concepts, so get ready to act fast. Feel free to pause the explainer if you need an extra second to think, and let's see what you've learned. For our first multiple-choice challenge, think back to the very start of the cycle. What does the I in IPO stand for? Is it A, idea, B, input, C, inside, or D, instruction? Lock it in. If you guessed input, you are absolutely correct. Input is always that crucial first step.
getting the data into the system. Next up, let's look at the brain of the machine. Which specific part of the computer actually handles all the processing? Is it A, the mouse, B, the monitor, C, the CPU, or D, the keyboard? Fantastic job if you went with C. The Central Processing Unit, or CPU, is the ultimate processing powerhouse, working on all that data. Let's test your hardware knowledge real quick. If you want a physical copy of your final result, which of these is an output device? A, keyboard, B, mouse, C, scanner, or D, printer? Spot on. The printer is what gives us our physical output on paper. The keyboard, mouse, and scanner? Those are all just for putting data in. Okay, let's rapid-fire match these columns. Input links to the keyboard, since that's how we enter data. Process connects to the CPU, our brain. Output links to the monitor, where we see the result. A real-world example of the IPO cycle, that's making a mango shake. And the device working only on numbers? Yup, that's the calculator. Let's keep this energy up with some true or false. A computer can work without instructions? False. It totally needs our commands. The CPU processes the data. True. Absolutely. A mouse is an output device. False. Strictly input. A printer gives us output on paper? True. And a computer has less memory than a calculator? Definitely false. Let's apply all this to a real-world scenario from the text. So, suppose a student named Krishav creates a digital masterpiece in his paint program. He's finished processing his artwork, and now he wants to actually hang it on his physical wall. What specific device does he need to get that drawing out of the computer? He would use a printer. The printer acts as that physical bridge, transforming his processed digital data into a tangible output he can actually hold. To wrap up today's explainer, I want to leave you with a critical thinking puzzle straight from the textbook. Think about how you physically interact with your machine. Which key on your keyboard serves the exact same purpose as clicking an OK button with your mouse? Think about how you finalize your input. Next time you sit at a computer, test it out and see the IPO cycle in action for yourself. Thanks for joining me, and I'll catch you in the next explainer.